We're almost there. We're almost there. In this lesson, we'll calculate the probability that a token occurs given that the email is spam. So in this case, we might calculate the probability of Viagra occurring in an email given that the email is spam. And then afterwards, we'll calculate the probability of a particular token occurring given that the email is a non-spam message. So I'll add this as a markdown cell. I'll say P parentheses token pipe spam parentheses probability that a token occurs given the email is spam. Now, we're not going to just do this for a single token. We're going to do this for all the tokens simultaneously. I'm going to store our results of this calculation in a variable called prob underscore tokens underscore spam. And I'll set that equal to the following. We're going to take our summed spam tokens and divide those by the spam word count, right? This will divide our summed spam tokens, our 2,500 values of how often each word occurred in spam emails, and we're dividing it by the total number of spam tokens. But there's one modification that I have to make to this calculation, and that modification has to do with what we did over here. It has to do with our Laplace smoothing technique. We added 1 to our summation because we don't want to end up dividing 0. Now, since there were 2,500 words where we added 1, we have to balance that out again. And this is why we're going to add the vocabulary size to our denominator here. We've added 1 2,500 times, so therefore we also have to add 2,500 to our spam word count to fully implement this smoothing technique. And that's it. We've done a lot of legwork, so it's just one line of code for that calculation, which is really, really neat. The thing you're probably wondering about, though, is what do the probabilities actually look like, right? Prob underscore tokens underscore spam square brackets colon 5 will show us the first couple of entries in this series. So here we see the actual values that we get. Now, the numbers that we're working with aren't particularly large, but if we sum them all up, they should add up to 1. That's how probability works, right? Prob underscore tokens underscore spam dot sum parentheses will show us if our math ties out. And I think it does. We've calculated the probability of the tokens given that the email is spam for all our 2,500 entries. Now let's do the same thing the other way around. So I'll quickly copy my markdown cell here, paste it in, change this to markdown, and change this to ham, and change this to non-spam. This calculation is very similar, right? Prob underscore tokens underscore non-spam will hold on to the token probabilities. And that's going to be our summed ham tokens divided by, open parentheses, the non-spam word count, so the total number of words in the non-spam messages, and we're going to add 2,500 since we're also using the Laplace smoothing technique here. There we go. That line calculates all the probabilities, and we can do a quick check here that these probabilities indeed sum to 1 or very close to 1 by calling the summation method and hitting Shift Enter. There we go. I'm pretty happy with that. Okay, so where does this leave us? We've tackled the fraction in the numerator, but we haven't tackled the fraction in the denominator yet. This here is the overall probability of a particular token. I'll add that as a markdown cell. I'll call it P token. This is the probability that a token occurs, regardless of whether we're dealing with spam or non-spam emails. So what I'll do is I'll create a variable called prob underscore tokens underscore all. And that will be equal to our full train features summed up across the columns axis is equal to 0 divided by the total word count. That's it. Again, this probability should sum to 1. So let's just quickly check if we've done this calculation right. Looks good. You'll notice that I haven't done any Laplace smoothing here because I'm pretty much guaranteed I'm not dividing by 0 because we've taken the 2,500 most frequent words in our whole data set to be our features. Now I think it's a good time to save our trained model to a text file and kind of create a checkpoint for ourselves. At the top of our notebook, where we've got our constants, I'm going to copy these 2 lines, paste them in again, and there I'm going to create 2 new constants. The first one will be called token underscore spam underscore prob file. I'm going to save this work to a different folder, namely our testing folder. So I'm going to replace 02 underscore training with 03 underscore testing. And this text file shall be called prob-spam.txt. I'll do the same thing for our non-spam files. So token underscore ham underscore prob underscore file will save as prob-nonspam.txt. The goal is to save both of these text files under 03 underscore testing inside our spam data folder. Going back up to the constants, I'll quickly add another constant up here for all our tokens. So token underscore all prob file. I'm going to call this file prob-all-tokens. And I'll hit Shift Enter on this. Then I'll come down here, and this is where we save the trained model. We're again going to use NumPy's save txt function, and we're going to call it 3 times. First time for the spam probabilities, where we're going to save prob underscore tokens underscore spam. We're going to call it again for our ham tokens, so token underscore ham underscore prob underscore file, comma prob tokens non-spam, and we're going to do it one more time for all the tokens. So this is going to be ham and spam combined. There we go. Saving data to the disk as a file is a really nice way of creating like a checkpoint for yourself. At least this way you can pick up where you left off and you don't have to rerun the calculations that you've done before, and you can always work off like the same text file. You can always work off the same data. It's not going to change.